Now that we've established the what, we need to define the actual loading magnitude from the code. But as you may know, this can be extremely different. The lateral surcharge load magnitude is going to be a function of the distance from the surface loading and the size of the surface loading. So in AASHTO section 3.11 loads, you can also backtrack here to figure out what we're using for our active earth pressure that is explained in the basic design course. And in section 3.11.6, we will find our surcharge loads. Note that regarding load factors, you can use table 3.4.1-1 to find the load factor for various service, strength, and fatigue uses. Also, section 3.11.7 specifies that bridges and culverts can have up to a 50% load reduction, but we won't go into that in this lecture because we're using the allowable strength design method, and we're just going to find the actual full loading that we're going to define from the code. Now we want to navigate to section 3.11.6.4 for live surcharge load. We're only worried about vehicles driving by on nearby roads for the most part. So this is classified as a live load. First, we need to see if the surcharge load even applies. The code here describes that within a distance equal to 1/2 wall height behind the back face of the wall. So a surcharge load applies if, for example, we have a 3-meter soil height and the vertical load is within 1.5 meters from the back of anchor, as shown in the diagram here. Second, if the load qualifies, we have two options. We can follow the design loadings, which is either found in Article 3.6.1.2 for a design loading or specified by the road owner. Or we can estimate the surcharge loading with equation 3.11.6.4-1 here on the right. First, we'll discuss the estimation. Following the equation, the terms are as simple as follows. We have our surcharge load, our earth pressure coefficient, our soil weight, and our equivalent soil height. All of these things we should have already calculated at some point, but except for the equivalent soil height, which we can find in table 3.11.6.4-2 for abutments perpendicular to traffic. Here's a screenshot from the code, and we'll want to use this table as, parallel to traffic, because our wall runs is generally going to run parallel to a road. But we'll use table 3.11.6.4-1 if the wall run perpendicular to the road. So say our road is in a plan view. Our road is as follows. If our abutment looks like this, note that our back wall is actually parallel to the road. And if our road runs like this, in this case, our wall is actually perpendicular to the road. And we'll do some practice problems below to go through this calculation and compare its magnitude to the earth pressure we are already using. And finally, we can discuss the design loading option. Article 3.6.1.2 in AASHTO LRFD specifications gives the specifications for design vehicles. We would then want to convert that loading to a point load or a line load shown here and use the following equations to calculate the surcharge. This may be necessary to sharpen the pencil, but can be highly variable based on how you interpret the code for the design vehicle or the load. Because of this, we recommend using the method of approximation first. And if we need to sharpen the pencil further, we can go in to use one of these specific equations, make assumptions based on what our design vehicle may look like.